Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're looking at our second section in Chapter 3 and we're going to be exploring how to solve systems by the substitution method. And if you missed the first session, 3.1, we learned how to graph two lines and find the point of intersection and then have an x and a y comma answer. We're going to do the same thing for solving systems, but this time we're not going to use it by graphing, which is a very difficult method to use because sometimes I end up with answers that might be 3/7 or something that's very hard to determine. So graphing can be imprecise. It's hard to see. We're going to have a little bit more accuracy using the substitution method. So the substitution method is really helpful when I have something like x equals, because then I can actually substitute the value of x. Well, if x equals 3 minus y, every time I see that x, I can plug in the value of x for it. So instead of saying 5 times x plus 3y equals 5, I'm going to take that value of y and plug it in for x. So that's called the substitution method. So instead of 5x, I've got 5 times the value of x, which the first line is telling me x is 3 minus y. The key here, in my opinion, is to replace x with parentheses. So I rewrite the problem without 5x, but 5 parentheses, and then in the parentheses goes the value of x. So you can practice that. Don't go too fast because then weird things happen. So combining like terms, we got 15 minus 2y equals 5. Subtracting off 15 is a negative 10, and y turns out to be 5. So it looks like we're only half done, but actually you're much further than half, because all we have to do now, being that you have the two answers, looks like you have half of them, but all we have to do to get the other half is plug that in for the y, because it says x is equal to 3 minus the y value. Well, the y value is 5. And sure enough, 3 minus 5 is negative 2. A nice way to check that answer is, since I used line 1 to solve for this negative 2, I would quickly just check. It takes like 10 seconds. Let's check it with line 2, because I found this negative 2 from line 1. So let's just check that negative 2 with line 2. So 5 times the negative 2 plus 3 times the 5 better equal 5. And it looks like it does, because negative 10 plus 15 certainly does check. 5 equals 5. So it's a quick way to check your solutions. Plug them both in. They should solve both 1 and 2 for systems. And here's how the author solved through it. The author even went ahead and graphed the function, but again, that's not necessary for the substitution method. So one of the hard things that students always tell me for the substitution is they don't know what to solve for, the top x, the bottom x, the top y, or the bottom y. So I have a bunch of problems here, and I thought we'd just practice. It looks like for this first problem I would solve, it looks like the top y is already solved for, so I take this top y value and plug it into the bottom. Same thing here for number 2. Take that top x, but plug it into the bottom for the bottom x. For this one, I would take the bottom, and that's the value of x, and I'd plug it into the top. And again, the bottom, I'd plug it into the y value up top. So instead of 9x minus 2y, I would have 9x minus 2 times the y value equals 3. And again, if I'm plugging in for the y, notice I'm replacing that y value with parentheses, and then whatever that y value is, I just place it right in there. So in the y value would go the 3x minus 6. But it's helpful to rewrite it in parentheses. Looks like this t I can solve for pretty quickly by subtracting off 5s. So 8 minus 5s will probably get plugged into the top. Down here, I'd probably solve, either I could solve for the top m, as in monkeys, or I could solve for this bottom n. So I don't want to solve for the 2n, because I would have to divide through by 2, and then that ends up with fractions. So always look for a leading coefficient of 1. That's the easiest thing. I'm going to solve for the bottom n. You can use the top m if you'd prefer. But the bottom n, if I subtract off 4m, and then I'll plug in to the top. Down here, looks like the y is already solved for, so I'll plug it into the top. And it looks like the top t is already solved for, so I'll plug it in to the bottom. This t I can solve for pretty quickly by adding 5s. So 5s plus 11, just a little bit of work before I plug into the bottom. This, a little bit of work, just add 3y to both sides before you plug it into the top, x. If both, well, this one's easy. Just plug it into the bottom y. If both variables have coefficients in front other than 1, it makes it a little bit more difficult because you have to choose either to solve for the p or solve for the w, because the directions say solve using the substitution method. So we don't want to use the graphing method, and then later we're going to learn linear combination. So follow the directions so I can see the process that you're solving for this. But I would look at this top equation, divide through every term by 2, and that way I can get a leading coefficient of a 1 in front of the w. So if you rewrite that top equation by dividing everything through by 2, which it's an equation, you can do whatever you want as long as you do both sides, we get 2p minus w is equal to 16. If I add the w to the other side, I have 2p is equal to 16 plus w. And then last, I would just subtract off the 16. So 2p minus 16 is that w value. Remember, I solved for the top, so that would get plugged in to the bottom right here. So instead of 5p minus 7w, I would write down 5p plus 7 times the w value, 2p minus 16, and that better equal this 1 right here. And then most students are on their way. So again, if I have a system that doesn't say x equals or y equals, you need to choose to either solve for x or y first. And it doesn't really matter. You could solve for x in the top equation or solve for y in the top equation. Anything with a leading coefficient of 1 would work. So I'm going to solve for this top x. You could solve for y if you'd like, but I'm going to say x is 6 minus y by subtracting y from both sides. And I'm going to plug it into the bottom. So that's an x value, so I'm going to plug it in here. So I'm going to rewrite. Notice instead of 5x, I write 5 parentheses. I would encourage you to write the whole rest of the equation so you don't forget the 8, which some students do. Then we plug in for the x. And in this case, x is 6 minus y. Let's finish this one up. This actually says 30 minus 5y plus the 2y. Notice the 5 does not get distributed to the 2y. Combining like terms, 5y take away 2y is negative 3y. I'll subtract off 30 from both sides. There's other ways to solve that, but I'm going to subtract 30, which is negative 22. And if I divide through by negative 3, this is not a nice answer, so I'm really glad I did not do the graphing method, because I don't think I would have ever graphed 22/3 accurately. So it looks like, again, I'm halfway done. Make sure you plug that in for the y value. That's not an x. So looks like I'm half done, but I'm a heck of a lot more than half done. Now all I have to do is choose either equation 1 or equation 2 and plug this y value in. Well, I'm going to go to equation 1 because it looks a heck of a lot easier. So instead of saying x plus y, I'm going to say x plus the y value, again, using my parentheses, and then in that y value goes 22/3. That's the same thing as saying x plus 22/3 equals, well, if I multiply the bottom by 3 here, I can multiply the top by 3 and get 18/3. And then if I subtract off 22, 18 minus the 22 will give me negative 4. And that's the x value. Again, that's kind of hard to check, but I would. I found this x value from the equation 1, so I would check this point using equation 2. It doesn't look real nice. Maybe even use a calculator, but 5 times the negative 4/3 plus 2 times the 22/3 better equal 8. And maybe you could just pull out a graphic calculator and punch that in and make sure that that does work. Hopefully it does. Let's see. Did the author get the same answer? Looks like it. Y equals 22/3. And, yep, did I have a negative 4/3? Yep, negative 4/3. Good. So the author and I agree. Let's move on. The perimeter, there's a formula for the perimeter. The perimeter, I would always suggest drawing a picture, but there's another length and a width here, so the definition of the perimeter is twice the length plus twice the width. So I'm going to start with that. It says the perimeter, which means twice the length plus twice the width, means equals 268. The next sentence here says the length is, so I'll say length is, that's how you translate this English into a math equation, is 34 feet longer than the width. So I'm going to go 34 more than its width. So if I go 34 more than my age, then I usually start with my age and then add 34. So that's why I'm writing 34 plus something, and then I write W plus 34. So this looks like I've set it up pretty good for substitution. I've got L is equal to W plus 34, so I'm going to plug that in for the L value. So instead of twice L plus 2W equals 268, I'm going to replace L with parentheses, and then in the parentheses goes my W plus 34. Again, I would really strongly recommend you rewrite the whole equation by replacing L with the parentheses. Let's finish this up. 2W plus 68 plus another 2W equals 268. Well, if I subtract off 68, looks like I have 200 over here, and add the 2 W's for a total of 4 W's, and then divide through by 4, and I should end up with 50, because 4 goes into 25 times. So then I'm going to plug that 50 right here for W. I have a nice equation. The length is 50 plus 34, because I know the length is W plus 54. Well, W is now 50, so let's write 50 plus 34. So the length is 84. And you can certainly write that as an ordered pair, but it might make more sense to leave it. The length is 80, because if you just write 8450, I don't really know if you're doing length and width or width and length. So I kind of like L and W, L equals and W equals. Here's the author working it out. You're welcome to pause the video and look at that, but it looks like they got the same thing. W is 50 and the length is 84. And again, it doesn't look like they wrote it in an ordered pair, so I probably wouldn't either. It's nice to state the final answer. The width is 50 feet, don't forget about the units, and the length is 84 feet. Again, recapping, I would take the top and plug it into the bottom. This one's kind of unique because you just end up with 3x plus 5 equaling negative 3x minus 2. So if you add 3x to both sides, what happens if you end up with a false statement? Well, we looked at this at a previous video, but I want to remind you, this is the empty set. That means the two lines are parallel and there is no solution. You don't need to graph it, but remember, this was an inconsistent solution. So let's try this again. X is already solved, so let's plug it into the bottom. So I'm going to replace x with parentheses, finish the whole sentence. Instead of 4y minus 2x equals 2, replace x with parentheses, and then in the parentheses goes the x value, and x is 2y minus 1. Let's finish this up by distributing the negative 2 to each term. So negative 4y plus 2 equals 2. This drops out, and this time instead of a false statement, I end up with a true statement, which means the opposite of no solution. I have infinitely many solutions if I end up with a true solution. That means it's a dependent system, and one line falls on top of the other line. So line A and line B are equivalent to each other, and that means every point, there's a lot of them. In fact, there's infinitely many solutions. Now, careful, you don't want to say everything works, because this point right here does not work for either solution. So you just say infinitely many solutions. There's some story problems I want you to read through. It looks like there's a rectangle going on, and they're talking about, again, the word perimeter. So I would start out with the perimeter is twice the length plus twice the width. And it looks like they give me the perimeter to be 60. So I'll write that equation. 60 is twice the length plus twice the width. Sometimes it's easy to reduce these things and make the numbers a little bit smaller. So if you wanted to say 30 is equal to the length plus the width, that might make equation 1 a little bit simpler to work with because now you have no leading coefficient in front of L and W, and the numbers are smaller. Let's keep reading. The length is 5 times the width. So the length is, and then 5 times the width means multiply 5 times the width. So if the length is already greater than the width, I'm going to have to multiply the width by 5 in order for it to be equal or balanced. So again, looks like I have a pretty good substitution. If L is 5W, I'm just going to plug that in right here for L. So instead of writing 30 is equal to L plus W, I'm going to replace L with parentheses like I've done the entire lesson. And then in here goes the 5W. That gives me 6W's is equal to 30, so the width better be 5. And once I determine that the width is 5, it looks pretty easy to get the length because, well, I know that the width and the length adds up to 30, so the length better be 25. Last example, airplane totals 150 seats. So I've got first class. Instead of saying x plus y is equal to 152, you might want to try to keep track of what's the x variable and what's the y variable. So coach plus first class, the number of coach seats plus the number of first class seats is 152. So I'll get rid of x and y, and I will label the variables with something that makes sense to me so I can keep track of which is coach and which is first class. You can always go over here and define x is the coach and y is the first class, but that takes some time. So I'm just going to use C and F instead. So here goes. The number of coach is, so coach is 5 more. Now we talked about that before. If I go 5 more than my age, then I would start with my age and increase it by 5. So 5 more than what goes here? Well, it says 5 more than 6 times the number of first class. So 6 times the number of first class is 6F. Finishing up this problem, I've got a nice value of C, and I'm going to plug that in right here. So instead of C plus F equals 152, again, notice that I'm writing the entire equation, replacing C with the parentheses, and then in the parentheses goes a 6x plus 5. You'd be surprised how many people have a difficult time with that, so slow that process down. 6x, these parentheses look like multiplication, but they don't. I can just drop them. So 6F and F is 7F, and if I subtract off 5 from both sides, I'll get 147, and it looks like I'm in trouble, but fortunately for me, 147 divides nicely, which kind of makes sense because I don't want there to be a third of a seat on an airplane. So I think F turns out to be 21. You can check that. So if F is 21, I'm going to go back probably to this equation. So I know C plus the 21 equals the 152. And if I subtract off 21 from both sides, I'll get C equals 131. So again, I would probably leave this answer. F equals 21, C equals 131, because if you were to write it as an ordered pair, I'm not sure if the number of seats for 131 is the coach or if 131 is the first class. You could always just write it out, and then I'd be convinced that you understand. But again, instead of just putting an ordered pair, I would probably put label your answer. I hope this video was helpful. Email me with your questions. Thanks.